So today we are going to enter into another topic of verbal logic. Interesting topic. Huh? So far with me, we've done a few sessions on vocab. We started with a few photo exercises and a really fun session where everyone was, participating, a lot of energy. We continued that into another type of question called analogy. So this is the topics that I did last week. And in verbal logic, I also covered an interesting topic called parajumble, which I think everyone had fun solving, rearranging the sentences and, trying to make the best combination. Meanwhile, Praddy has started grammar for you. So Praddy started with parts of speech, prepositions, conjunctions, and he also went into reading comprehension. So this is what we covered with you all last week. This week, I'm going to start with this interesting topic called syllogisms. Okay, so it's part of verbal logic. It's part of critical reasoning. And to introduce syllogisms to you, I'm going to take you through what is an argument. Okay, now this is not an argument which you have with your friends or with your. Acha, Praddy's done tenses also. So grammar mein tenses is also done. Yeah, so let's add tenses here. Okay. So argument is not something that you are going to have with your parents or with your brother or sister or with your friends. Okay. Argument is something that authors use to convince us about their point of view. So whichever author is talking about some topic in the passage or in the question, it's called an argument. It is made up of two things. One is when you have facts, which are called premises. Yeah. And the other part of your argument is a conclusion, which is a deduction based on the premise. Now, one thing to remember is that in the premises which we are told, for the purpose of your question, the actual premise may or may not be true in the real world. Okay, you may be given some nonsense premise also. Like, for example, all fruits are blue. If I say this as the premise, see, we know that very few fruits are blue. In fact, I can't name any, maybe grapes, if you say purple. But you may be given all fruits are blue, all flowers are red, right? So you have to trust this premise for the purpose of your question. You can't say that this premise is false. Whatever is given to us in today's questions, we have to just assume that the premise is true. Okay. And from that premise, we try to reach conclusions. From what is given, whether we can judge another sentence is true or not, which is your conclusion. So let's take a few examples immediately. Argument made up of premise and conclusion. Yeah. I've put up two premises on the screen. Now, as you can see, as I explained, this premise may not be true in the real world, but in our question, it is assumed as true. All cats are dogs. It may sound a bit weird. Huh? It's okay. All cats are dogs. And Rocky is a cat. So these are two premises. Can we say conclusion is okay? Is it a valid conclusion? Yes. If all cats are dogs and Rocky is a cat, that means Rocky is one of our all cats, and by extension, Rocky is also a dog. Okay. So this is our premise. And based on the two premises, we drew a conclusion. Now we only have to decide in the rest of our slides today whether our conclusions are valid or our conclusions are invalid. That's all that we are going to do. So from the premises, when we have a conclusion statement, can we say it is true based on the premise? We can definitely say conclusion is valid, or there is some doubt. There is a possibility which the author has not considered, in which case conclusion becomes invalid. Okay, so it's valid when this has to be true. Given the premises, this has to be true. Then it becomes valid. So let's move on. As we've been doing before, with this class, I like to do more of practice, more of problems than teaching. Concepts are very few. Yeah, we only have to judge whether conclusion follows from the premise or conclusion does not follow from the premise. That's it. what we are going to cover in today's class. And I have many questions lined up for you. Acha, before we proceed, some of my questions today might need a notepad to solve. Okay, so if you have a notebook or something kept next to you with a pen and paper, it will be helpful. Today in some question, we'll be using Venn diagrams to solve it. Huh. So is this valid or invalid? Yeah, what about this one? Okay, so we have a few answers, A1B0, Sheikh, Gayatri, Mohan also. Some are saying one valid, some are saying, so this is all one argument. Huh? This is all one argument. This is not two different statements. It's all the same question. And we have to say overall, based on these two premises, so this is premise one and this is premise two. Because this word has a therefore, we can say this is a conclusion. So based on these two premises, premise one and premise two, can we say conclusion is valid or invalid? This is what we have to judge. Okay, so there are 25 CDs on the top shelf of my bookcase and 14 on the lower shelf. From this premise, we come to know there are two shelves. There may be more. We don't know yet. But we know there are 25 plus 14, 39, top shelf, lower shelf. Second premise tells us there are no other CDs in my bookcase. So there may be other shelves. We don't know. But no other CDs on those shelves. Okay. So we definitely know there are 25 on top, 14 below, and no other CDs. Therefore, there are 39 CDs in my bookcase. So this is a valid argument. Yeah? 25 plus 14, 39. Not invalid. Yeah, let's do one more similar kind of argument. Here we have three premises. Premise one, premise two, premise three. And this is your conclusion based on all of these. Okay, this time we have started in the replies with more invalid than valid. More people saying invalid. Okay, so Topeka is either in Kansas or Honduras. See, sometimes na, in these type of question, make a diagram if it helps. So what does premise one tell us? Topeka is either in Kansas or in Honduras. Simple. So this is premise one. If Topeka is in Kansas, then Topeka is in North America. So if we go this way, then Topeka is in North America. If Topeka is in Honduras, then Topeka is in Central America. But bearing in mind, this is if. It's not telling us where it is. So therefore, can we say Topeka is in Kansas? No. There's nothing actually relating these two. Everything is if and or. It's either Kansas or Honduras. And if Kansas, then North America. If Honduras, Central America. So this conclusion is not valid. It does not hold. Right? Invalid. There is no connection to prove that Topeka is in Kansas. All we are given is this situation. It can be here or it can be here, either of them. Okay. So is this fun? Just deciding whether conclusion is valid or invalid. Simple. Now I'm going to make it a little bit more difficult. You have two premises. So this is premise one and this is premise two. And we have two conclusions. And we have to choose one out of these four options. Okay. So one quick tip when we solve these, try to remain within what the premises are telling you. Okay. Don't get into information that is outside the premise. Only concentrate on this. And when you see a solution, if any conclusion is related to the premises, you judge whether true or not. If any conclusion is not related to the premises at all, then forget about it. It's unrelated completely. Don't try to judge true or false. Just ignore. Okay. So all the students in my college are intelligent. Can we say this as if this is a group of intelligent students, all are intelligent in this. All the students in my college are intelligent. So can we say students from your college are here? Okay. There may be other intelligent kids also who are from other colleges, right? We don't know. But all the students from your college are intelligent. So we have this kind of a diagram. Now, Shreya is not intelligent. Okay. So Shreya is outside this circle. So she may be here, or she may be here, or she may be here, anywhere. But she's outside the circle of intelligent students. So can we say that Shreya is not from my college? Yes. If she can't be inside the larger circle, she can't get into this. Then it's not possible for her to get into the smaller circle. So it automatically means that Shreya is not from my college. Okay. Can we say Shreya should study more? Is there anything in the premises which is suggesting how to become intelligent? No. Author is not saying anything on those lines. Okay. It's just giving us a situation of intelligence level of various colleges. And as Sheikh is saying, all the students from SRKR are intelligent. So you are all within this circle. Good. Perfect. I have noticed that in my last few classes. Okay. So this is not a valid conclusion. This can be said, second one cannot be said. So in this case, only one conclusion follows, which is the first one. So we had to choose. If second one was valid and one was also valid, you would have chosen both. And if neither was valid, you would have chosen 4. Okay, so here this was okay and this was not okay, invalid. So we choose the first option. Okay, any doubts? That was quick and that was easy also. Yeah. These are your exam questions. Huh? So, okay, interesting question from, I'm not getting your name, 1C6. I can see Bhagi, but I don't know whether that is long short form of something. Huh? So we consider individual statements? See, you have to consider both premises together. That is how we got this diagram on the right, both premises. When we consider conclusion, we have to consider individual conclusion, only one at one time. So from these two premises, can we say conclusion 1? Then you decide whether valid or invalid. Yeah. Then forget conclusion 1 and then from the premises, can we say conclusion 2? Valid or invalid? So both conclusion have to be considered separately, not together. But both premises have to be considered together. Okay. So let's quickly do another one. Chalo. Good. I'm really happy with the number of answers coming in. Huh? It tells me that all of you all are solving, all of you all are following. So keep it up. Keep up this energy throughout the week. I know it's only the first day, but let's try to have some fun. And I think by the end of the week, we are closing the course. I mean, the sessions might come to an end by, I think, by Saturday. Huh. So Taj Mahal will survive the threat of acid rain. Okay. So that's premise one. And it has stood the test of time for many centuries. So premise two is talking about it was built in, I think, what, 17th century, 16th century, sometime 2-3 centuries back. And it is still standing. And it will survive the threat of acid rain. So this is talking about the past, and for whatever 200-300 years that Taj Mahal was built. And this is talking about the future, will survive. And as we know, all the premises that are given to us are accepted as fact. Okay, you can't question. So if author is saying will survive, will survive. Although reality we know is different. But we should try not to bring our knowledge from outside the question into our paper. We have to only rely on what the author is telling us. Okay. So now from these two statements, can we say acid rain is not common in many parts of the world? This is a completely unrelated statement because this is talking about acid rain in other parts of the world. Our author is talking about two premises only in Taj Mahal. Okay, it's not talking about acid rain in different parts of the world. Rishi has a good example. If author says Taj Mahal is in Mumbai, you have to accept it is in Mumbai. You can't say it's in Agra. Okay, so author is saying will survive. That is first thing you note, and past tense and future both. So acid rain common in many parts of the world, unrelated. So this one we ignore. Now second one, and the key. Acid rain may damage parts of the Taj Mahal. Is the second one contrary to your first premise? If Taj Mahal will survive the threat of acid rain, it means that it cannot damage. Okay, so this becomes contrary. It's a contradiction to what is given in the premise, and premise is always true. So contrary becomes invalid. So in this case, we have neither one nor two, because one was unrelated and two was opposite to your premise. So therefore it becomes invalid. You can't draw the conclusion. So neither one nor two follow the statement. Okay. So this is the way in which examiner will try to confuse you. Premise and conclusion. Concentrate on what we are trying to judge. Ignore the unrelated parts. Okay, shall we do one more? Now I'm just going to increase the difficulty level one bit, slightly more difficult. And we have to choose only one conclusion. Choose one, please. So variety of answers now. I've got, some are saying 1 is okay, 2 is okay, 3 is okay. Some are saying 3 statements are true. No, only one statement is true and others are invalid. Okay, this is more of logical reasoning than verbal ability. Yeah, maybe I should start taking LR classes also, along with Deepak. Yeah. So many offices located in buildings have 2 to 8 floors. So let's list out the buildings here. Let's do it simple. So this is building 1, this is building 2, building 3, 4, 5, 6, 7. Yeah. Building 1 has 2 floors. So only first and second floor. Building 2 has 3 floors, 4 floors, 5 floors, 6 floors, 7 floors, 8 floors, right? All these the conditions, right? Now it says if a building has more than 3 floors, it has a lift. So does this building have more than 3 floors? No. So can we say no lift? Does this building have more than 3 floors? No. So can we say no lift? This one has more than 3 floors, 3 floors. So lift is there in all of these buildings. Yeah. Building 3 to building 7 have lift. So all I'm doing is I'm putting the problem in a pictorial representation. Okay. Now we come to the conclusion. So we've covered the premises, premise 1 and premise 2. Can we say all floor may be reached by lift? This is true.
No.
The buildings which have a lift. But what about the buildings which don't have a lift? There are 2 floors here and 2 floors here. So these 5 floors cannot be reached by lift because there is no lift. So how can you reach? So this is incorrect. Only floors above 3rd floor have lift. Do you think this is right? It is said only buildings which have more than 3 floors have a lift. So this building does not have a lift and this building has a lift. But is it mentioned anywhere that lift will not stop on 1st and 2nd floor wherever they have a lift? Yeah, in every building, when there is a lift, it stops on all the floors, not necessary that it will go directly to the 4th floor and rest have to climb the stairs. No. So this is also incorrect. Whichever buildings have a lift, it may stop in all floors. There is no information provided to us saying that it will move only to the above floors. No. Third one, the 5th floor has lift. So does this building have 5th floor? No. Does this have 5th floor? No. 5th floor? No. Has 5th floor? Yes. Has, and has. And all the buildings which have 5th floor, can we say that they have a lift? So therefore, all 5th floor, whichever building it may be, has a lift. So this is okay. Okay, 3B6 is telling me a special situation in which hostel lift is not stopping for 1st and 2nd floor. Okay, so this is particular to your hostel, and I'm sure they want you to get a bit of exercise if you stay on 1st and 2nd floor. But in this question, it has not been told to us that on the buildings where there is a lift, whether it will stop in 1 and 2 or not. So we can't say this second statement that it will be only for the higher floors. We can't say. 5th floor has lift. All the 5th floor have a lift. So we identified these buildings. All of them have a lift. So this one was okay. Can we say 2nd floors do not have lift? So does all the buildings have 2nd floor? Yes, all the buildings have 2nd floor. 2 of them do not have lift, these 2, and 3 of them have a lift. So we cannot say that 2nd floor do not have lift. This is not true because some have, some don't have. So this is also incorrect. 3 is your right answer in this one. Okay, interesting question from 249. Why should we not think that all the conclusions are related to one building? But that's because the premises are talking about many buildings. So you can't keep all the conclusions only for one building. Okay, Bhagi has another doubt. In the given statement, other than stopping, why can't we say regarding having the lift? I haven't understood your doubt, Bhagi. So other than stopping, why can't we say regarding having the lift? Just explain it a bit better and we'll come back. Praveen also has doubt. Statement doesn't talk about 5th floor. Praveen, that's right. Statement doesn't talk about 5th floor, but many office buildings have 2 to 8th floor. So you have to consider all the possibilities. Even though 5th floor is not explicitly mentioned. It's okay. Some want an explanation to second option. Only floors above 3rd floor have lift. Okay. So for those buildings who have more than 3 floors have a lift. So these buildings have more than 3 floors, which I am circling now. Okay. But they also have first and second floor. They have more than 3 floors, but they have first and second floor. So all of these buildings, first floor, second floor, third floor, fourth floor. This is this building. First floor, second floor, third floor, fourth floor, fifth floor. This is this building, right? Now, when they have a lift will stop at all the floors. It's nowhere told that it will not stop any particular floor, right? So in these buildings, first and second floor get a lift, even if you are on lower floors. And in these buildings, first and second floor don't get a lift because there is no lift only in the building, in these buildings. So only floor above third floor have a lift cannot be said, because in all of these buildings, the floors below third floor also have a lift. So this becomes invalid. Second one. So it stops on first and second floor. It is not imagination, Praveen, unless there is something given which is contrary. We can't say that it is true. That if it doesn't stop on first and second floor is mentioned somewhere, then only. Otherwise, no. We assume that lift will stop on all floors. Okay, there's another one for conclusion 1. If we take a building more than 3 floors, okay, then first conclusion may follow. Yes, all floors may be reached by lift. But here you're talking about all floors in all buildings. You can't concentrate on buildings more than 3 floors. Yeah, A3G3. So this is all floors. So that includes floors in these buildings as well. So they don't have a lift, so you can't reach them by lift. Yeah. Okay. So yes, slightly confusing, but we have to work at it from the logical perspective. So now let's move into a type of question which can be answered using Venn diagrams. It's a continuation. Same type of question, but instead we start solving these questions in the form of pictorial representations. Okay, so now I want you to go back to your 10th standard, your 12th standard, and maybe your first year of engineering, where we had covered Venn diagrams. A intersection B, A union B, right? How will you represent no A or B? We put 2 circles. One has A, all elements are called A, and one has B, all elements are called B, right? And no A or B means that these circles cannot overlap. There will always be a separation between these circles. These are also called mutually exclusive events, from those who remember, right? So now in the premises, we are going to face statements like this. Okay, no A or B, some A or B, all A or B. This is what we are going to face, and we have to solve it using Venn diagrams. Any doubts in this? Does anyone remember what we studied in set theory? And back then, I don't remember when. Yeah. Okay. So some of you all have seen this before. So I'm just going to take you through a few situations which try to explain using diagrammatic solution how it will look. Okay. Now let's look at all A or B. Okay. The very simple Venn diagram which we can draw for all A or B is only one circle. And the same circle has every element which is both A and B. All the elements are both A and B. Okay, so this is an overlapping circle which is called A equal to B. All A are B. Okay, but is this the only way to represent all A or B? No. There can be some situations where some B are not A, but all A are B. So how will we draw that? There will be a bigger circle and there will be a smaller circle. The smaller circle will have A's and all A are B. So every element in this smaller circle is also A and it is also a B. But elements which are outside the smaller circle, but inside the bigger circle, these are only B's. They are not A's. If they were A, they would have gone inside, but they haven't. They have stayed outside. So elements which are in the middle part of the circle are B's which are not A's. Okay, so this still holds. This is correct. All A are B, but all B are not A. Okay, there are some B's who are not A. So this is another way to represent all A are B. Okay, so you have A equal to B in which all B's are also A. So all A are B and all B are A. And here you have all A are B, but all B are not A. So this is this one. Okay. Any doubts here in the second one? These are just two situations which we use to represent it visually, how it will look, the two circles. Now the third one, some B are A or some A are B. And the most common way to draw this is you draw two overlapping circles. Okay, one circle is A's and one circle is B's. And this part of the circle which is overlapping are the A's which are also B's. So all the elements here are both A as well as they are B. But there are some elements which are only A. They are not B. And there are some elements which are only B's. They are not A. Right? So by some A or B, we only come to know that this part of the circle has a few elements. We don't know anything about this part and we don't know anything about this part. Okay. Now, if I say that those elements which are only A are 0. So there are no A's which are not B's. Yeah, if I am removing this part. So then what does the remaining circle become? Yeah, you get this circle which is B's and then you get this part which is A and B. Right? So some A are B, this is holding, and some B's are not A's. So this has still elements in it. Or can we draw another circle this way? Yeah. Now suddenly some A or B has become similar to a diagram which we did on the last slide. Because we specified one more option. We specified another premise that those A's which are not B is nil. And when this happened, A became a subset of B. All the A's which are B's are inside B. There are some B's which are not A's. So it became like this. If we say that this is nil, B's which are not A's becomes nil, then this reverses. Right? Then B becomes a subset of A because there are no other B's which are not A's and some A are B. Those are inside this circle, the smaller circle. Right? So this part, this blue shaded area has gone to become this part when we added one premise and has gone to become this part when we added another premise. Right? And if both of these are nil, if both question marks I take out of the picture and I say both are 0, then you are left with only this area where all A's are B's. So this becomes A equal to B. Right? Or you can just draw a circle with A equal to B. Right? So this is just basics of Venn diagrams. And this is all that you need to be able to solve the questions that appear in this topic. You don't need to go anywhere beyond this. Yes, there are a few more challenging conditions. There are a few other complicated statements, but they are not asked in your exam. So don't worry about them, right? So using what we've studied so far, A is not B, A is some no A or B, all A or B, and some A or B. Yeah, these are three conditions which we did. Can we try and solve a few questions based on this? The questions are similar to what we did before, syllogisms. But now we are going to use this knowledge that we have gained on how to represent sets visually to be used in the questions. So your questions are the same, premise 1 and premise 2, and conclusion 1 and conclusion 2. And remember what we studied, only conclusion 1 follows, only conclusion 2 follows, neither and both. This is what we have to answer. Your answer will be either A, B, C, or D. Okay, so I have a variety of answers again. Some are choosing B, some are choosing C, and some are choosing D. A has not been chosen from anyone. Acha. So Teja, just to be different from anyone, and Avinash as well have chosen A as well. So now I have all four answers, which are on the screen. Interesting. Okay, so let's solve. We studied all A are B. And how do you represent it? All cars are cats. So cars becomes a subset of cats. Okay, so there is one bigger circle of cats and there is a smaller circle of cars. So I'm going to write cars here and I'm going to write cats here. All cars are cats. We have not been given any other information. So there may be some cats which are not cars. We don't know, right? For now, we only know this. And all fans are cats. So there is a bigger circle for cats and there is a smaller circle for fans. And all fans are cats. But are there any cats which are not fans? We don't know. But this is related, no? Can we use the same circle for cats and say all cars are cats and all fans are cats? Yeah. So what if there was a bigger circle, all are cats? Now, all cars are cats. So cars is also inside this circle, or fans are cats. So fans is also inside this circle. But within these two premises, we are not given the relation between cars and fans. Yeah, this is something we don't know. So whether they are independent, whether they're mutually exclusive, whether there is some part of fans which is overlapping with cars, there may be, or whether cars and fans are the same, so the entirely is overlapping. Yeah, this is something that we have not been told. So relation between cars and fans to each other is not known. So while this is not known, all cars are fans, we cannot say. Conclusion 1 does not follow, it is invalid. What did I say at the very start of my session? A conclusion has to be true from the premises for it to be valid. If there is some doubt, if there is some other possibility of anything else happening, then it cannot be valid. It has to be true. But in this larger circle of cats, we found out some examples where different situations were possible. Some cars are fans, no cars are fans, all cars are fans. All of this was possible. We've not been told about this. So therefore, first one is not a valid argument. Second one is also not a valid argument. Can we say some fans are cars, or all fans are cars, or no fans are cars? No. This relation has not been given to us. So therefore, neither one nor two follows. Both are invalid. Okay, so all possibilities are open. So interesting. I know a lot of you all got it wrong, but I hope the doubts have been solved. I hope you know why we are incorrect. Right? Some have chosen A, B, and D also. Okay, so now I'll give you another new question. Now let's continue our practice. Try to draw the premises in the form of your diagram. And once the diagram is ready, try to judge whether conclusion fits or conclusion doesn't fit. Okay, so I think this is easier because now I've got more answers towards one option and less answers of another option, and two options have not been chosen at all. Okay, good. And I do hope that some of you all are doing this mentally. So in case you need to draw, I am explaining it with the drawing, but it's a slower method. If you can visualize this in your head, what circle is inside what is linked, then that makes it much faster. So start your practice with a slower method. Do more practice as possible. So today evening, you will also have one new test on syllogisms. And that test will have more practice questions on this exact same questions that we are solving. Attempt it. Try to attempt with paper, try to attempt without paper. Okay. All of the questions in today's test have a video recorded solution. So I have recorded individually how to solve each question. So those which are not understood, you can have a look at the videos as well. And it will be just like our class is continuing. Okay. So let's put up first premises, premise 1 and premise 2. Some scooters are trucks. So what did we say about some A or B? Some scooters are trucks. So this is scooters and this is trucks. And I'm going to put TRU for trucks because there's another word for trains. We can put TRA. So those scooters which are trucks are here. I know it sounds weird, but we accept the premise which we are given. We cannot say our scooters are not trucks. No. Some scooters are trucks, okay, if you say so. All trucks are trains. So can we say in another circle, all trucks? This is similar to our last one. Trucks becomes a subset of trains. Yeah, all trucks are trains. Now, can we use this and combine the common one that we have? Did we say that some scooters were trucks here? So therefore, there is some part of trucks which is blue, right? Which are also scooters. So this blue part is both scooters as well as trucks, right? And this entire circle is a subset of trains. Or if we were to put this circle here, I would continue this circle and make it a much larger circle. right? And this becomes trains. Either way is okay. Some part of this circle we have put here to combine the two premises, or we have brought the larger circle here. So now we can see that trains includes all of trucks. So trains is the largest circle, trucks is this circle, trains includes all of trucks. But there are also some scooters inside the circle for trains. Those scooters which are trucks automatically become trains as well because of premise 2. All trucks are trains, but some scooters are trucks. So all trucks, those trucks which are scooters are also trains. So some scooters are trains is okay. This is valid. Can we say no truck is a scooter? But this is in direct contradiction of all trucks. All some scooters are trucks. This is a premise. And what did we say? Premises are always true. We cannot contradict. And no truck is a scooter is a direct contradiction of premise 1. So this becomes invalid. And we have A for this one. Okay. So understood, everyone? You first draw what are the premises, what is the situation. And then you try to put each conclusion into the premise. Okay, does it fit here? Does it fit here? Can this be a shaded area? And can this not? And we can say which one has to be true. No truck is a scooter cannot be true because some trucks are scooters. It is given right here. So I eliminated this also and this also because of my second step. Okay. Now that we've understood a little bit of basics of how to solve these, I'm going to put a little bit more difficult question on the screen. Okay, this had two premise and two conclusion, and we had to judge. One follow, both follow, all that. Yeah? Now I'm going to put up 4 arguments at a time. And we have to say which are valid arguments. And in each argument, first sentence is a premise, second sentence is a premise, and third sentence is a conclusion. And if these two premises can lead to this conclusion, then this becomes valid or invalid. And we have to pick the valid arguments. Okay, so this is a slightly longer question. So 1A8, we are looking at one of these options. We have to choose A, B, C, or D. So we have to judge 4 and then we have to choose. Not whether one is valid or not. I'm looking at 4 sentences. Good, and I can already see some options coming in, which is very nice to see. That's a very good speed to solve. Right. So since this is the first one, I'm going to do it. I'm going to solve it a little slowly. Okay. Some of you might find it a bit slow, but it's okay. Next one, we can be quicker. Yeah. Because some of us may not have actually understood still how to do it. So for them, let's go about it in a slower way. Some printers are fast. So we have simple Venn diagram. Some printers are fast. And those printers which are fast are here. Yeah. Some printers are not fast. They are these. And some fast may not be printers. So you may have fast other things. You can have fast trains, you can have fast fans, anything else. Right? So some printers are fast. That's all we know. And no fast is slow. So let's make another diagram where fast and slow are two mutually exclusive events. No fast is slow. So these two circles cannot overlap. Right? Now let's try to combine these diagrams. Can we use this circle of fast and put printers on top of it? Right? So this is the same thing which I've brought this side. Yeah. Some printers are fast and no fast is slow. Okay. Now, can we say no printer is slow from these two? This is your premises, premise one, premise two. And we have to judge whether conclusion is valid or not. See, relation of slow is given to fast. So we know that this circle of fast and slow cannot overlap. But slow can be anywhere else. Slow can be here. Slow can be here. Slow can also be here. In that case, slow and printers is overlapping. So we cannot say for sure that no printer is slow, because the relationship between printer and slow not being given, slow can be anywhere else. Okay. So this is invalid. This statement does not hold. Rishi, I'm not getting what you're saying. My diagram is CRT. Huh. You just have to no poet is a thinker. So coming to the next one. See, any doubts in the first one? Anyone who's not understood how we reached invalid? So this one is invalid. Huh? Now we're just deciding valid, invalid for the rest. And now we can go a little bit quicker. Now we know how to make the diagram. Sorry, I think, yeah. No poet is a thinker. Oof, what is happening? So we have poets and we have thinkers. And this is mutually exclusive. So these cannot overlap. Okay. So 311 has a doubt. What statement should be there in order to make valid? We'll come. There are a few valid ones in this also. We'll spot it. Don't worry. So no poet is a thinker. Okay. Some thinkers are leaders. So can we use the same diagram now? Some thinkers are leaders. And those are the thinkers who are leaders. So no poet is a thinker, mutually exclusive. Some thinkers are leaders. This is premise one and premise two. Can we say no poet is a leader? No, because we don't know the relationship between poet and leader. Leader can be here as we have drawn. Leader can be here, in which case no poet is a leader. But leader can also be here, in which case some poets will be leaders. So this is possible. So this is also an invalid statement. We can't guarantee that this will be true. Okay. So yeah, like 311 is asking, for judging whether the statement is possible, we need some relation to be written between printer and slow in the first one, or between leader and poet in the second one. If there was a statement specifying that relation, we could have placed this circle a little bit better. But right now, all these options are open. It can be placed anywhere, as long as part of it is overlapping with thinkers, this dark blue part. Okay, so both of them are invalid. First one and second one we've eliminated. So this one is also eliminated. And if second one is eliminated, this one is also eliminated. And if second one is eliminated, actually this one is also gone because this has B. So that leaves C and D. But just to make sure, we should verify whether C and D are valid or not. We shouldn't just choose. Elimination is allowed. Huh? So if by elimination method you are able to reach your answer, please select and move on. But just to verify, we should solve also, which we'll do. So now we have the same situation. No poet is a thinker. So we have poet and we have thinker. And this will be mutually exclusive. Some thinkers are leaders. This is leader and some thinkers are leaders. Right? Can we say some leaders are not poets? Now, in the previous one, we thought where else can we put leaders? We can put here, we can put here, we can also put here. But these leaders who are thinkers, from the first premise, no poet is a thinker. These leaders who are in dark blue will never overlap with poets, right? Because the circle for thinkers and poets is always mutually exclusive. These dark blue areas can never go and overlap with this circle. No. Any other leader can overlap, but dark blue will not. So, yes, we can say that there will always be some leaders who are not poets. And these are the leaders, the ones who are in dark blue. They will never be poets because thinkers and poets cannot overlap. So C is okay. Yeah, so C is mentioned here and C is mentioned here. And coming to the last one, only cats are dogs. Okay, now what does this only mean? It means that all cats are dogs and all dogs are cats. It is not a subset of each other. It is fully overlapped and exactly the same circle. Okay, only cats are dogs. So these are all both cats and dogs. Okay, Praveen, I've seen your doubt. I'll come to it after solving this last one. Huh? So only cats are dogs is here. No cat is a pig. So can we say no cat is a pig? These are mutually exclusive. They will always have separation, cannot overlap. But if we use this diagram and come here, this is the diagram for cats, which is also the diagram for dogs, and there's a separate circle for pigs. And if cats cannot overlap with pig, then dog also cannot overlap with pig because only cats are dogs. There is no other animals who are dogs and there are no other animals who are cats. So if no cat is a pig, then it also means no dog is a pig. So D is also okay. Your answer was C. C and D were valid statements and A and B were invalid. Okay, so slightly longer question may take a few students in the class a bit of time to understand. But my suggestion is go by the diagram method. It is slower, but it will always get you your answer. There is no confusion. Slowly, with more practice, as much as you can, the diagram which we are drawing here will start coming in your mind. You will start to visualize, okay, here the circle is here, overlap is possible, not possible. When it becomes mental, it becomes faster. Then you don't have to draw it. Then you'll be able to quickly solve these problems. It will come with practice. Don't worry. Okay, so Praveen had a doubt. If in C, which is here, the conclusion says all leaders, so here says some leaders are not poets. If the conclusion says all leaders are not poets, then is it invalid? Okay, some leaders, so no poet is a thinker, which was here. Some leaders are thinkers, which we drew. And if you want to replace this with some goes out and it becomes all. All leaders are not poets. Okay, so therefore leaders can be here, leaders can be here. Okay, but Praveen, you cannot say this for sure. No? What if leaders is here? Then this doesn't hold. So it becomes invalid. All leaders are not poets becomes invalid because you can't judge. It's the same as this. Yeah. Okay, so let's do one more. Good. I'm really happy with the speed at which some of you all are solving. Very nice. Good to see. So I've received two answers mostly. Some of you all have gone for A, and some of you all have gone for D, D for Delhi, which is basically A and C, both. So let's have a look. Anyone who's still solving? Maybe, okay, 30 seconds more and you can put, and we'll start. Acha, Rishi is saying if all is there, then it's simple. And when some is there, then it becomes a little bit difficult. Yeah, that's true. Okay, so all music is good. Yeah, so let's come downstairs here. All music is good. Can we say music is a subset of good? So there can be some other things which are also good. Food can be good. Yeah, anything else also can be good. So all music is good. And all good is great. So we have good and we have another circle called great. So this is our two premises. Premise one, premise two. How do we combine the two? All music is good and all good is great. So let's just put a bigger circle for great over here and we take out this. So all music is good, all good is great. So therefore, if music is a subset of good, automatically it becomes a subset of great, right? This inner circle has to be inside the middle circle and the middle circle has to be inside the outer circle. So by default, inner circle became inside the outer circle. So all music is great is okay. This is valid. All men are wise. Okay. All men are wise. And all wise are leaders. So you have wise and you have leaders. Can we combine these two? Yes, we can. All men are wise and all wise are leaders. Same method. And then we take this out. Can we say all leaders are men? No, not necessary. All men are wise. There may be some wise who are not men, first of all. And all wise are leaders. There may be some leaders who are not wise. Right? So, although everyone in this larger circle are leaders, there are leaders who are not wise and not men also. Then there are leaders who are wise but not men. So all leaders are men, we cannot say. This is invalid. This does not hold. Okay. Now, all men are wise. So we have the same situation. So let's just continue with this. All men are wise and all wise are leaders. So same circle. Okay, we are here. Can we say some men are leaders? We have men, which is a subset of wise, and wise is a subset of leaders, right? So we can say some men are leaders because those men who are inside the circle, some men, all men, doesn't matter, they are leaders. If all men are leaders, by default, some men have to be leaders, right? So this is okay. So this is valid. I think this was the confusion between those who chose A and not D. The confusion was that whether some men are leaders is the same thing as all men are leaders. It's not. Some men are leaders doesn't mean all men are leaders. There are some men who may not be leaders. But all men are leaders means some men are leaders. Okay, if all men are leaders, some men have to be leaders, right? This holds. So this is your confusion. Amin wants me to explain B again. Okay, all men are wise and all wise are leaders. All men are wise here and all wise are leaders. So therefore, does it mean that all leaders are men? No. All leaders are inside this bigger circle. I mean, there are people here who are not wise, but they are leaders. So these are people who are leaders, but they are not wise and they are not men. Yeah? They are only leaders. Then these are people in the middle who are leaders, they are wise, but they are not men. And these are people who are inside, who are leaders, they are wise, and they are also men. Okay, so these are the three situations for this circle. Yeah, a few more doubts coming in. Only some men are leaders is wrong. This one, is it? No, but some men are leaders, no? These are the men who are inside this circle. Okay. Right. Acha, we want more explanations and more doubts. So some are saying that this class has been useful because when these questions came up in college, we were unable to solve. But now with the help of Venn diagrams and how to sort out what the premises are, it's doable. Good. So I'm happy to hear this, B103. So such feedback is always helpful, you know. Go about it simply, go about it in a slow manner at first. And when you start practicing, when you start getting the answers right, then try to speed up. Okay. Yeah. So this brings us to the end of our class today. I know we are a few minutes early, but that's okay. Maybe you guys can have a longer break before your next class. Okay. Was this fun? A simple topic, syllogisms, starting with premises and going into conclusions. Okay. So in the next class, we'll continue and we'll keep having fun. Please take care, all of y'all. Thanks for attending. And I'll see you again this week. I think I have 2 more classes with you. And of course, you will be seeing Prady also as well. Chalo. So it was good to meet you all again. Have a good week. Have a good day ahead. And keep some energy for later classes also. Okay. Chalo. Bye-bye. Thanks for attending.